In example 2, we're told that Susan is dragging her best friend Jim across the grass at recess. She's dragging Jim at a constant velocity of 0.3 meters per second. This is an important fact that we will come back to. You're asked to draw the vectors that show the forces acting upon Jim. So the first force is the applied force of Susan dragging Jim. This is shown as 67 newtons, and you're told that this is acting to the right, which is in the positive direction here. You're also told that there is a friction force acting upon Jim. Friction always opposes motion, and clearly Susan is dragging Jim to the right, so friction must act to the left in this case, and you're also told that it is a force of 67 newtons. You're asked to determine the net force acting upon Jim. Net force is the sum of all forces, and in this case it is the applied force minus the friction force. Remember, the positive x direction is to the right, so the applied is positive. The negative x direction goes to the left, so friction is negative, so you're given the applied force minus the friction force. 67 newtons minus 67 newtons is a net force of 0 newtons. I'm sorry about the missing t here in net force. You're asked to understand what this means by determining, are the forces balanced or unbalanced? Balanced forces are forces that completely cancel out. If the net force is 0, then the forces are balanced. You're also asked to determine what the first law says will happen to Jim. Aside from getting dirty, we can assume that Jim will continue to move at a constant speed. You're told that he was at a constant speed of 0.3 meters per second at the beginning of the problem. If the forces are balanced, Newton's first law says motion will not change. So Jim will keep moving at the constant speed that he was already moving. 0.3 meters per second, we can assume to the right because that is the direction Susan is dragging him.